There will be some questions in the midterm exam from this SQL part. Yes, there will be SQL. Mr. Damas select where, select from where group by having. So, inshallah. Okay, so now today we have another topic that we will take here today. Let me put this on recording. We have normalization. Today, inshallah, we'll take that. A bit about this. We have taken this. We talk about this. Okay. So our topic of discussion will start today from normalization. It's a prayer call. Just 2 minutes, inshallah, we'll start. Normalization, and this topic will be, the topics are covered from the chapters of the book Punya. Now here, normalization is an approach to create a set of tables that represent a real world information. Okay. So in data modeling, basically we see two types of data modeling: conceptual data modeling based on the concepts, and normalization, which is relational data analysis. So in this course, we will be talking about this normalization. So what is normalization? It is an approach to create a set of tables that represent a real world information. So whatever the information we want to represent here, we want to represent that in a set of tables. And these tables are somehow related by using foreign keys, okay, to create a relational database. Fine. So in this part, we'll be talking about normalization and representing the relationship between the tables, because normalization creates a set of tables, and these tables need to be connected. There should be a relationship between the tables. So we need to also study how we represent a relationship between the tables. We already talked about the foreign key in our last meeting. So foreign keys are used here to create a relationship between the tables. So first thing is that normalization. So in this normalization part, the problem associated with the unnormalized data. So what are the problems associated with the unnormalized data, which is not normalized? Then what is the process of normalization and the circumstance when it is advantageous to denormalize the data? So we will be studying this one. After we study this, right, we should be able to explain the problem associated with the unnormalized data, which is unnecessary duplication of data resulting in update, modification, is delete, and addition anomalies. So there are three main problems of unnormalization, which is update anomaly, delete, and insert anomaly. These are three problems with unnormalized data. And that's why to avoid this problem, we do normalization. So we need to know what is update anomaly, what is a delete anomaly, and what is the insert anomaly. Anomaly in the sense problem. Okay. Now, first thing is that let us understand these anomalies first, fine, before we talk about the normalization. So I think I have that here as an example. We take that in the activities. Okay, so here is the discussion. Fine. So there are three types of problems or anomalies. Okay, there are three. The Punaya chapter 10 described this. There are three types of anomalies or problems that can arise when we attempt to modify unnormalized form of data. So what is unnormalized form of data? Any data we take from the source. Okay, for example, this is the data which we took from the source, right? That where there is a patient and prescribed by some doctor. So this relation you can see here. We have patient information, doctor information, and the drug information and the prescription. So for example, here if you take patient P001, Thornton, Dr. D06. So this patient associated with this doctor, Dr. name Gibson, on date 15th May 2014. The drug code is this, which is given to this patient. The drug name is this, what is the dosage and what is the duration. Similarly, the same doctor and patient on 15th of May taken the drug this one. So actually this data is here. Okay, it is came here, but it should be like this. Then what is the dosage? How much the dog will take? So you see, this is an unnormalized data. This is unnormalized data. That the data we copied from the source directly, which include all the information, right? That is called an unnormalized data. So what is an we have here is that we have patient ID, patient name, doctor ID, doctor name, drug date, drug code, drug name, dosage, and duration. Okay, so this is all what we have here from this table. From this table, what we have is this. So our table is this one. That patient ID, patient name, doctor ID, doctor name, date or in which the doctor see this patient, the drug given to this patient, drug name, what is the dosage, and what is the duration. So this data is an unnormalized data. The first thing is that what are the problems with this unnormalized data? Okay, every data we said that we will use a primary key, right, to identify the data or identify a particular object or to identify a particular patient. So in this one, if I want to select a primary key, I have to go for the uniqueness. So patient ID, you can see it is repeated. Doctor ID is also repeated, right? Uh, Patient name, doctor name, everything is somehow repeated here. So there is no one single primary key which is unique, because the primary key, what is the property of primary key? It should be unique and not null. It should be unique and not null. So here we see that if we don't find one key as a primary key, we can combine the different keys to make that as a primary key, so that it will be unique and not null, and by which we can identify the records or the data. Now, if I combine a patient is seen on a date and given a particular drug. So if you combine this patient ID with date and drug name, you will find patient ID on the date with the drug code. It will be unique. Okay, you will not find P001 on this date with the same drug code. Right? You can find P001 on the same date but a different drug code. Similarly, P001 on another day with different drug code, or it can be same drug code. Similarly, P001 on another date, okay, with different drug code. So we see that these three can form a primary key. So we underline them as a primary keys. We underline them. We can also see that, okay, what can be the other primary keys in that. But the primary key we already discussed, but just we take a recap of that. Our main concern here is to identify the anomalies, the problems with this unnormalized data. So if we said that with unnormalized data, which is not normalized, there is a problem of update, delete, and insert. Update, delete, and insert. Now, what is an update problem? Update problem or the anomaly results in a data inconsistency because of a possible partial update instead of the proper complete update. Okay. Now, for example, suppose that the drug tramadol prescribed on 15th of May was actually prescribed to the patient tenant rather than Thornton. So to correct this error in the relation, it will be necessary to update the values of patient ID, patient name, doctor ID, doctor name attributes of the first row over here. Okay. So let's say this drug is assigned to not Thornton but to another patient. So in that case, it should update this with all other attributes. Okay, update with all other attributes. So if the patient ID attribute was P001 and updated to P07, it results in an update anomaly as the patient P007 will be called both tenant and Thornton in the relation and will be under the care of two doctors. So what I'm trying to do that we are trying to update part of the data in the table that creates a different meaning in the data. Like we are trying to update, no, this drug is given to patient P007, not to P001. It came by mistake here. Okay. So what we'll do, we'll change this to P007. Now P007 Thornton will take this drug, whereas P001 is tenant, not Thornton. So you see that P001 takes two names, one's tenant, one's Thornton. So which one is correct? Which one is correct? So there is a problem here that because of this update, okay, the data is inconsistent here because of this ID update. This is called update anomaly. So in general, update anomaly is the problem that exists because of making an update inside the data or inside the system. The update will be a partial update and this creates an inconsistency in the data. This is called update anomaly. We also have a delete anomaly in the same case. Delete anomaly results in unintended loss of data because of possible deletion of data rather than what must be deleted. Okay, for example, suppose that drug tramadol prescribed on 15th of May was actually prescribed to any other, not actually prescribed to any of the patient. So we need to delete the first row. Okay, but if we delete the first row, we are deleting the information, other information also. Okay, so if you look at this data here, so this tramadol, we want to say that tramadol is not assigned to this patient. So we want to delete this here. But if you delete tramadol from here, then the tramadol will be deleted and you see that there no exist tramadol again. So meaning that this data will be completely deleted. At the same time, you'll also delete other data. You will also delete other data. This is called the delete anomaly. Okay. Finally, insert anomaly. In insert anomaly, this also brings the data in an inconsistent state because if you want to add some data, okay, the absence of other data will prevent the adding or make the table in an inconsistent state. Yes, Firas, do you have any question? هذه هو Yes, normalization. لا normalization. لا هذه فإنه أنا بشرح لك أمامك إن شاء الله بشرح لك إيش normalization كيف نعمل normalization. الآن إحنا شايفين المشاكل بدون normalization. إيش المشاكل بدون normalization؟ عندنا ثلاثة مشاكل. هذا data، هذا البيانات اللي موجودة أمامنا، هذا with unnormalized data، بمعنى إنه هذا data أخذنا من المستشفى، إنه في patients وفي دكتور وفي drugs والprescription. هنا البيانات هذه حق الدكتور وبيشنت وبريسكريبشن، ليش الوصفة الدواء، ففي جدول واحد، كل المعلومات في جدول واحد. فعندنا repetition زي ما انت شايف انه patient repeated here، doctor is repeat. ايوه في repetition. وغير الريبيتيشن انا عندنا problems في الابديت، في delete وفي الانسرت. فهذا ايوه نعم، فهذا البروبلمز اسمه anomalies because of the unnormalized data, because we did not normalize it. Fine. So what is normalization? Normalization is a process to create the tables, more tables from this unnormalized data, so that you don't have any problems. Problems of update, problems of delete, problems of insert. So what is problems of update? For example, let me just explain you what is the problem of update. In this case, what is the problem of update? For example, let's say that I want to update this patient ID, okay? Because this patient ID, I did not assign this drug to this patient ID. So meaning that I want to change this patient ID, okay, because this drug is for another patient. So I will put it here. The new ID is P007. I gave this to P007, not for P001, not for P001. So إذا غيرنا هنا إلى P007 فإيش صار الآن؟ صار P007 اسمه ثورتون، أوكي، والدكتور وهذا دكتور دي 06 وجيبسون والديت والدراج. فعندنا P007 كمان هنا، وإيش اسمه البيشنت تننت. فP007 باسم ثورنتون باسم تننت، هذا خطأ. وP007 بشايف من الدكتور دكتور دي 07 ودي 06، اوكي. فبسبب الابديت هذه صار الخطأ انه واحد بيشنت له اسمين، فهذا خطأ بسبب ال unnormalized data زي هكذا. فهذا سميه update anomaly. update مشاكل الابديت. في مشاكل الديليت، يعني من هذا البيانات إذا أنا أعمل ديليت في هذا البيانات، مثلا أنا تتغير إنه هذا ترامادول drug، هذا ترامادول fine does not exist، فبنعمل ديليت. فنعمل ديليت كيف؟ أنا إذا عملت ديليت هنا في هذا الرو، عملت ديليت الجميع البيانات هنا، أوكي. طيب أنا أقول لك ممكن نعمل هذا من، ايوه بتاريخ الاي دي. ممكن نقول انه لا تعمل الديليت، سلبي هذا النل، خليها نل. ولكن احنا عندنا دراج كود هذا من الكيس حق البرايمري كي، فكيف ناخذ نل في برايمري كي؟ ما نقدر اخذ نل في برايمري كي، لانه برايمري كي نوت نل، برايمري كي دائما نوت نل ويونيك. كيف هذا بيصير نل؟ ما يصير نل. فهذا مشكلة الديليت. اوكي، احيانا في مشاكل ثانية انه اعمل ديليت للبيانات واحدة واسوي ديليت نفس الرو في بيانات الاخرى، اعمل ديليت مع بعض. اوكي، فهذا مشاكل الديليت. في مشاكل insert على هذه، مشاكل الانسرت. مثلا انا دحين عندي patient P008، اوكي، اسمه فراس، وجديد هذا patient، دخلت البيانات وما شاف الدكتور ولا شاف ولا اخذ الدواء. يعني he did not see the doctor, he did not take the prescription. So in that case, I'm not going to enter anything here, anything here, anything here, nothing here, all this nothing. فعندنا هنا خطأ لأنه فيها مجموعة هي من البرايمري كي، يعني من تبع البرايمري كي، فهذا ما يجوز، يعني this is not true. fine. فهذا يسبب مشاكل، كمان اسمه insert مشاكل. فبيانات هكذا زي كذا اسمه unnormalized data دائما يسبب المشاكل الأساسي هي update delete وinsert. سموه problems معنى anomalies معنى problems. there will be update anomaly, there will be delete anomaly, there will be insert anomaly. طيب الحل لهذه المشاكل هو normalization. ايوه، نحول الجدول هذه الى اكثر من واحد جدول نشيل هذه المشاكل، يشيل هذه كل المشاكل، وهو normalization. فكيف نعمل normalization هنا؟ طيب هذا unnormalized data. اوكي، في unnormalized data the first step to represent the data in a tabular form. يعني أول شيء نحط جميع البيانات في جدول. okay, in a tabular form. Usually we draw the table like this. Okay, and we'll put all the data in the table form like what we just saw. مثلا هكذا التيبل، أو اللي شفنا الآن التيبل هكذا. fine, this table prescription table. okay, we put first the data in a form of table. okay, and we select one or more attribute as primary key. Fine. So first thing is that put the data in a table and select the primary key. So here we choose the primary key as we saw, patient ID with drug code and the date the patient has seen. Okay, so if you put this in this form, this is unnormalized data, and we want to, first thing is that we normalize. So normalization, there are different forms of normalization. There is a first normal form called 1NF, second normal form 2NF, third normal form 3NF. There is BCNF, Boyce code normal form. There is fourth normal form. There exists fifth normal form, and so on. So the best is that if you do the normalization up to 3 normal form, third normal form, your data will be consistent and there will be no problem of update, delete, or insert if you normalize up to 3 normal form. So in this case, we do up to third normalization. Now, what is first normal form? First normal form is that a relation mana hina table, jadwal, is in first normal form if each attribute contains only atomic values, that is, it has no repeating group of values. يعني ما يكون متكررة، الvalues متكررة في جدول. Okay, so إذا أنا عندي جدول, if I have the table where we have repeated values, what we can do to represent the data in first normal form, remove any repeating groups of data to a separate relation, and to a separate table, and choose a primary key for each new relation. Choose a primary key for each new relation. So in our case, in an unnormalized data, what we see above, there are several values of date, drug code, drug name, dosage, duration, attribute column for each patient. So patient P001 prescribed tramadol, omeprazole, semavastin, and other drug. So patient is repeated many times. Okay, patient is repeated many times. When the patient is repeated, its doctor is also repeated. Right? So these items are repeating groups and are removed to a separate relation, separate table using relational algebra project operation. The new relation has a primary key comprising of patient ID, date, and drug code attribute. A patient may be prescribed several drugs on the same day or may be prescribed the same drug on different days. So what we do here is that we are going to remove the repeated groups, that is the patient repetition. So what is repeated here? Patient and doctor information is repeated for every prescription. If you look at this table, for this patient, okay, doctor is this, and we have 3 prescriptions or 4 prescriptions. So 4 times patient ID is repeated, doctor ID, doctor name, and patient name. This is repeated. Similarly, for P007, tenant, Dr. D07 Paxson is repeated for 3 times. This you can see here clearly. Yeah, here. So you see what is repeated more here. The patient ID is repeated, patient name is repeated, doctor ID, doctor name is repeated. Okay, patient name, patient ID, doctor ID, doctor name is repeated. Okay, now what we do, we take this as a separate group. We take this as a separate group. I have here. No, I don't. So what we do, we'll take this as a separate group. We say patient ID, patient name, doctor ID, doctor name in one table called patient doctor table. Okay, whose primary key is patient ID. Okay, and here we keep patient ID because it is a part of the primary key. We keep the date, drug code, drug name, dosage, and duration. Right, and for this relation, what is the primary key? Patient ID, date, and drug code. So here patient ID, date, drug code, the primary key, and all other, you can see drug name, dosage, duration is included here. So you see now 2 tables. From one table, patient prescription table and patient doctor table. So we got 2 tables in first normal form. Okay, now you see that there is no repetition of the data. Do you see repetition? Takrar, no, we see patient P01, Thornton D06, and here patient P01, date and drug code. It is unique. Patient P01, date and drug code, different drug code. So patient may be given different drug code on the same day or same drug on different days. So it will not be repeated. So you see that there is no repetition and there is a primary key, and hence these these 2 relations are in first normal form. Okay, so this is how we make the first normal form. Now after first normal form, we move to second normal form. So a relation is in second normal form if it is in first normal form. In الشرط الأول هي لازم يكون في first normal form. بمعنى there should not be any repeated rows and repeated data. Fine, and there should be primary keys. So a relation is in second normal form if it is in first normal form, and every non-primary key attribute of the relation is dependent on the whole primary key, that is without partial key dependencies. Without partial key dependencies. So what does it mean? It means that if I have a primary key, Okay, I have a primary key and non-primary key attributes. So if I take this table, prescription table, what is the primary key in this table? Patient ID, date, and drug code is a primary key, right? So primary key here is patient ID, date, and drug code is the primary key. What are the non-primary key attributes? Yes, what are the non-primary key attributes in this? Yeah. Yes. لا كيف ما انت قصدك انه ما ناخذ اكثر من واحد كولوم للبرايمري كي؟ لا، كيف ليش ما ناخذ؟ احنا نشوف البرايمري key should be unique. So if there is no one key that is unique, we can combine with another key to make it unique. Yes. امم لا، هذا اذا انت اخذ البيشنت كي لحاله كبرايمري كي لحاله، بيشنت اي دي لحاله كبرايمري كي، هذا ليس برايمري كي لانه في تكرار هنا، فما يصير برايمري كي. فاذا انت اخذ الديت لحالها كبرايمري كي ما نقدر لانه في تكرار. واذا اخذت انت دراج كود كبرايمري كي هنا في جدول هذه ما نقدر لانه في تكرار، لانه ممكن في بيشنت ثاني ياخذ نفس الدرج، في تكرار. ففي هذه الحاله ايش نعمل؟ ناخذ المجموع الكيس كواحد. مثلا اذا انا اخذت البيشنت اي دي والديت مع بعض، فنشوف يصير ما في تكرار. مثلا بي 001 15 ماي، فهذا في next row بي 001 15 ماي، ففي تكرار هنا. فبما أنا لا، ليست هذا ما سميه جدول، هذا سميه كولوم أو attribute. أيوه attribute. فهنا ما نقدر ناخذ الاثنين، فندور الثالث. الثالث هو دراج كود. مثلا ناخذ دراج كود، فإذا أخذنا دراج كود بي 001 15 ماي والدراج كود تي 02378 يتكرر مرة ثانية في جدول؟ ما تكرر لأنه patient واحد مثلا patient P001 on date 15th May will take the drug T0237. He will not take the same drug on the same day again. Okay, he will take only once. So it will be unique now. So if we combine these three attributes, make the primary key, which is unique. So that's why we combine it to make the primary key. Okay. تمام. البرايمري كي الآن هنا هو composite key. هنسميه هذا composite key. إذا أخذنا أكثر من واحد attribute لبرايمري كي، هذا سموه composite key. composite بمعنى مجموعة الكيز. فأنا primary key الآن هنا patient ID date ودرug code صارت primary key. وإيش ال non primary key attributes؟ What are the non primary key attributes here? Yes, what are the non primary key attributes? It's very important. يعني أي non أيوة not primary key. Yes, yes, very good. So non-primary key attributes here are drug name, dosage, and duration. Okay, these are non-primary key attributes. So what is in the second normal form? What the second normal form says? Second normal form says a relation or a table in second normal form if it is in first normal form, and every non-primary key attribute of the relation of the table is dependent on whole primary key. without partial key dependency. So here every attribute, non-primary key attribute, should be dependent on these three. But we see that drug name is dependent on drug code only. If you know the drug code, you will get the drug name, right? So drug code is dependent, drug name is dependent on drug code, which is the part of the primary key. So it is a partial dependency. Okay, so you need to understand here the dependency between the attributes. Dependency between the attributes. So here I have a drug name and I have a drug code here. Drug name is dependent on the drug code. So if there is a drug code, meaning there is a drug name. For every drug code, there is a drug name. So if you know the drug code, you will get the drug name. So here the drug code, the drug name is partially dependent on the part of the primary key, which is the drug code, because drug code is a part of the primary key. So here there is an attribute called drug name, depends on partial primary key. So what about the dosage? Dosage depend on the drug code and the date when to take and who will take. So this is the dosage. Duration also depend on the which drug, on which date, and who is the patient. So these are not depending on partial dependency. Drug name has a partial dependency on the primary key. So meaning this table is not in 2NF. It is in first normal form, but not in second normal form. Okay, so this patient prescription is not in second normal form. So how about this table, patient doctor table? Is this table is in second normal form? So what we do here, we see the partial dependency. Okay, what is the primary key? Primary key is patient ID, only patient ID. So there is no question of partial dependency because it has only one primary key. When the relation or a table has only one primary key, there cannot be any partial dependency. So this table is already in second normal form, this patient doctor table. But this above the prescription table is not in second normal form. So in that case, what we will do, so to represent a data in second normal form, we remove any attribute that only depend on part of the primary key to separate in a separate relation and choose a primary key for the new relation. Okay, so this step only applies to the relation with a composite primary key. Composite primary keys means that is a primary key that has more than one attribute. Okay, like here. The primary key is PID, date, and drug code. So you have more than one attribute. This is also called composite key. So 2NF is applied only when you have a composite key, and we have only one primary key. It is already in 2NF, so you don't need to apply. So in this case, there can be a partial dependency, like drug name depends on drug code, which is a part of the primary key. So it is a partial dependency. Fine. So what we will do here, we'll take out the drug code and the drug name into a separate table. So what we do, we will take out drug code and drug name into a separate table. We'll keep the drug code here and drug code and drug name as another table called drug. So we'll create a table called drug where we have a drug code and drug name. And what will be the primary key? Drug code will be the primary key. And here, from here, we will take out this one will be take out. And this relation will have only patient ID, date, drug code, dosage, and duration. This is prescription. And the primary key is PID, date, and drug code. Fine. So this table now it is in 2NF and this here is in 2NF. Okay. So drug name is removed with the drug code and the drug name will be a new relation. So you can see this is the drug table and this is a prescription table. So the primary key in the prescription table is this again, and the primary key here is drug code. So how many tables we made till now? We made 3 tables. Yes, this is prescription table, this is drug table, and we also have another table called patient doctor, which is having patient ID, patient name, doctor ID, and doctor name, where patient ID is a primary key. So you see, we unnormalized data is in one table. We do first normal form, it comes in 2 tables. We do second normal form, now we have 3 tables. This is what normalization is. Okay. Now we'll move to third normal form. What is third normal form? A relation is in third normal form if it is in second normal form, and every non-primary key attribute of a relation is wholly dependent on the whole primary key and not any non-primary key attribute. So first thing is that the table should be in a second normal form. Okay, the table should be in second normal form. So second normal form, it means there is no partial dependency. Then the second rule here is that every non-primary key attribute should be fully dependent on primary key and not dependent on any other key, any other non-primary key. Okay, there should not be a partial dependency, that is in second normal form. And here in third normal form, there should not be a trivial dependency or a transitive dependency, meaning that one should not be the non-primary key should not be depend on non-primary key. Every non-primary key should be dependent on the whole primary key. Okay, so if I take simple example here, let's say I have A as a primary key, B and C. Now in this case, B should be dependent on A and C should also be dependent on B. But if C is depends on A and A is depend on the primary key, sorry, B is depend on primary key A, this is what we call it as a transitive dependency, and this table is not in 3 normal form. So we want to remove this transitive dependency in third normal form. So where do we have this transitive dependency? If I take these tables, for example, let's say that I have 3 tables here. Okay, what are the 3 tables? I have prescription. This is prescription table. Okay, this is a drug table, and I have a patient table, patient doctor table. The primary key for prescription, patient ID, date, and drug code, and for the drug is drug code and patient ID here. Now let us check the transitive dependency, or we check that every non-primary key attribute is wholly dependent on primary key. If we talk about the prescription dosage depends on the which drug, on which date, on which patient. So what it means, dosage is fully dependent on the primary key. Duration also depends on which drug, on which date, on which patient, or who is the patient. So meaning that duration is also fully dependent on this primary key. This is the primary key. So this is fully dependent on primary key. Dosage is also fully dependent on primary key. So this relation is already in third normal form. We don't do anything in this. Coming to this relation, drug, we have drug code and drug name. Drug name is dependent on drug code. This is fully dependent. So this is also in 3 normal form. So we don't do anything in this. Coming to patient doctor table, patient doctor. Now patient, here the primary key is patient ID. Patient ID, patient name, doctor ID, and doctor name. Okay. Now let us check one by one. Patient name depends on patient ID. Yes, it depends on patient ID because you know ID, you will get the name easily. Doctor ID, let's say, is depending on the patient because which doctor is seeing which patient. Okay. Taib, what about the doctor name? Doctor ID, if we say it depends on this one, but what about the doctor name? Doctor name depends on doctor ID, and doctor ID depends on patient ID, on the primary key, because to whom he is seeing the as a doctor, seen by this this doctor is seen, or this patient is seen by this doctor. So here there is a trivial dependency or transitive dependency, that doctor name depends on doctor ID and doctor ID is depending on the primary key. So it is same like C is depending on B, B is depending on A. So this should be removed. This is not in 3 normal form. This should be removed. So how we remove this is that you bring in doctor ID, doctor name in another table, which is doctor table. Doctor ID and doctor name, and doctor ID as a primary key. So this is a doctor table. And now from here, remove the doctor name. Remove the doctor name. So you will get a new patient ID, patient name, and doctor ID. A new patient table, patient doctor table. So here this is in 3NF and this is in 3 normal form. So how many tables now we have? How many tables we got now? Oh, 4 tables. We have 4 tables. We have a prescription table here. Prescription, drug, patient, doctor. 4 tables. Yes, this is in 3rd normal form. So we bring in here into 2 tables. And we keep the doctor ID here in the patient as a foreign key. To keep the relation between doctor and a patient, we keep the doctor ID here as a foreign key. Okay, so now our new relations after the normalization will get 4 tables, as you can see. And now you can see that there is no repetition of the data, and you can easily make an insert, update, or delete. For example, I have a new drug that I want to insert. I can insert in the drug table with the drug ID and drug name here. Okay, no problem. I have a new patient, okay, or I have a new doctor, I can easily add here. I have a new patient, I can add here with null as a doctor is not seen by any doctor. So doctor ID is not primary key, so I can keep it as a null here. No problem. Prescriptions, you want to make any changes in the prescription, you can easily make the changes in the prescription. Okay, so we see that we solve the problem of update, we solve the problem of delete, we solve the problem of insert by this process called normalization. And this is up to 3rd normal form. Okay, with the 3rd normal form, there will not be any update or delete or insert anomalies. And this is how you do the normalization. Okay, now I'll just recap this, that what are the 3 normal forms. 3 normal forms. First normal form, very simple. Every table should have a primary key and there should not be repeated groups. No repeated, should have a primary key and no repeated groups of data. Okay, in first normal form. What is in second normal form? It should be in first normal form. First should satisfy this. Then there should not be any no partial dependency. Partial dependency, meaning that what? No non-primary key attribute or column depend on part of primary key. No partial dependency means what? No non-primary key attribute depends on part of the primary key. This is in second normal form. Coming to third normal form, it should be the relation should be second normal form. It means it should satisfy this. So which means that it is in first normal form and it is in second normal form. Then the third normal form says it should be in second normal form and there should not be any transitive dependency. So there is no transitive dependency. What is transitive dependency? Means that no non-primary key attribute depends on non-primary key. No non-primary key attribute depend on non-primary key. So this is it, third normal form. If you do for any relation all these three, you will get this relation with no anomalies, no insert anomaly, no update, no delete anomaly. Okay, so these are the three things for in normalization, first, second, and third normalization. We have another example here. This is an invoice example. We have an invoice number, date, customer number, customer name, ISBN, the book, ISBN, title of the book, what is the quantity, what is the price. Okay, this is the invoice. So this invoice is one of the invoice. I think I have that invoice here. I will show you that. Just 1 minute. Yes. Okay. See this one. This is the invoice or the bill of the Amazon bookseller. Okay. So I have the information, invoice number, date, customer number, customer name, the ISBN, title, quantity, and the cost or the amount. You can take this. Okay. If I want to put this in a form of table, this is the table. Fine. Invoice ID, date, customer number, customer name, ISBN, title, quantity, cost. Okay. This is unnormalized. Why? Because there is a repeated group of data. Invoice number, date, customer number is all duplicate, repeated group. Fine. So we need to normalize this. So how we can normalize this? First thing is that you decide one primary key in this. Which can be the primary key? The customer takes the book, a book, okay, one book on one invoice. It can be one book on one invoice. So you can have a primary key of what? You can have a primary key of invoice number and customer number, or invoice number on the date with a ISBN number. Okay. Or you can have invoice number, date with this customer number. Fine. So you can decide this as one primary key. The next thing is that you remove the repeated groups to be in first normal form. So take out the repeated groups. Okay. So how you take out the repeated groups? How you take out the repeated groups? So for you have to take out, okay, what invoice number? Fine. So with the books, for example, every book, fine, kept with one invoice, fine, on the date for a particular customer. Okay. So we will get tables for customer with invoice and books with invoice, customer with invoice and books with invoice in first normal form. Second normal form, you remove the partial dependency. If there's any partial dependency, you are going to remove that. Okay. Like for example, if something is depending on part of the primary key, what we have selected. Okay. So if you have selected, for example, invoice and ISBN as a primary key, okay, so title depends on ISBN, which is part of the primary key. So in that case, ISBN and title should be separate. ISBN and title should be separate. Also, the cost depends on the ISBN, okay, the book. So title, ISBN, cost is a separate relation because of the partial dependency, okay. And then in third normal form, you will be looking for the transitive dependency, okay. So might be there customer name depends on customer number depends on invoice. So there is a transitive dependency. You remove customer number and customer name as a customer relation. So it is a transitive dependency is removed. Then you will get all these four as in first normal form, second normal form, and third normal form. All the relations sorted. Yes, Firas. مم. طيب انت عامل كيف؟ لازم. مم. طيب. طيب ايش الطريقة انت عامل في البداية؟ لما انت عامل في البداية هذا الشيء، اوكي، في البداية عندك الطريقة هذه صح؟ طيب او ايش هو الطريقة؟ هو نفس الطريقة صح؟ ايوه انا فهمتك، انا فهمتك. انت تقول لك انه ايش انا احط جدول واحد وبعدين اعمل اربع جداول. ايوه ليش ما من اول بحط اربع جداول؟ ايوه ايوه هذا السؤال، يعني هذا السؤال من عندك انه بدل ما نجيب جدول واحد وبعدين نحول إلى 4 جداول، من أول جيب ال4 جداول صح؟ طيب اللي طريقة أنت عامل ل4 جداول هو نفس الطريقة أوكي، بس هو informal. إحنا عملنا هذا formal بيسموه normalization أوكي. في نفس الشيء أنت عامل اللي أنت عامل نفس الشيء، بس هذا بالطريقة هذه أوكي. هذا طريقة مضمن إنه for sure no, there will not be any problems by this way. If I go by my own way, of course we are doing the same thing. يعني انت عامل نفس الشيء، انت عامل نفس الشيء اوكي من عندك، انه خلاص خليه جدول لحال للكاستمر، خليه جدول لحال للبوكس، وخليه جدول لحال للانوايس اوكي، او اوردر جدول لحال. طيب كيف اعمل ريليشن شيب بينهم؟ انت تجيب، ايوه انت ايوه عن طريق الفورين كيز، عن طريق التيبلز and so on اوكي، عن طريق الفورين. ايوه عن طريق الفورين كيز. ونفس الشيء هي الفيرست نورمال فورم، سكند نورمال فورم، عموما النورماليزيشن لنفس الشيء. انا عندنا فكره هذا نورماليزيشن، بس ما اعرف انه هذا نورماليزيشن. يعني كل ما ما في ما... لا هذا ليست مشكلة. جبنا المشكلة، أنا جبنا إيش؟ أنا شفنا إنه إذا في خطأ في الجداول أوكي، بيصير مشاكل الأبديت، ممكن يصير مشاكل الأبديت، ممكن يصير مشاكل ال الديليت، ممكن يصير مشاكل الانسرت. فهذه ثلاثة مشاكل يعني أساسي لجميع قاعدة البيانات أوكي. فكيف نحل هذه المشاكل الأساسية؟ هذه المشاكل نحل بطريقة النورماليزيشن اوكي، ايش نورماليزيشن؟ عندنا فكره نورماليزيشن بس انا ما اعرف انه هذا نورماليزيشن. احنا نعرف خلي جدول لحال للكاستمر، خلي جدول لحال لانفويس، خلي جدول لحال للاوردرز للبوكس. طيب انا اعرف انه لازم يكون جدول لحال للانفويس، لازم يكون جدول لحال لاوردر للبوكس. طيب في شخص ثاني ما اعرف انه هيكون الجدول كل واحد لحال، هو بحيث انه فكره انه خلاص خلي في جدول واحد. احنا شفنا في كذا مشاريع، يعني إنه شفنا في كذا مشاريع في مشاريع التخرج ان نجيب جدول واحد فيها بيانات جميع البيانات. طيب في مشاكل في جدول واحد، كيف نحل هذه المشاكل؟ فلازم كل واحد يعرف انه طريقة حل هذه المشاكل كيف، عن طريق النورماليزيشن. طيب اللي شغال في داتابيس، اللي شغال هو عارف شخص يعني formally or ايوه formally or informally. ما شاء الله انت شغال في داتابيس، انت عارف انه لازم يكون لحال، كل شيء لحال، انت عارف. بس انت ما عارف انه هذا الطريقة سميه normalization، لانه انت عمل هذا informally. اوكي، informally you do this but you don't do this as a formal way. You don't include it in your reports. Okay, that is the thing here. And there are who don't know about this. Okay, so by this want to bring in that you have to do these steps when you make a database, when you create a database. لما ننشأ الداتابيس لازم نعمل هذه الأشياء. ما يصير أو غير صحيح إنه نجيب واحد جدول لحال أو جدول واحد لجميع البيانات، غير صحيح. لازم نجيب نعم، 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 هذا هو. إيه، هذا عفوا. فهذا يعني this is an example of it. Okay, uh, I think it's very clear. If anyone has any doubt in normalization، في هذا أي سؤال في normalization؟ yeah, normalization شيء مهم. فحتى في إنشاء إنشاء الداتابيسز هذا شيء مهم. في الاختبارات برضه في أسئلة في النورماليزيشن. لازم كل واحد يعرف إنه كيف تعمل نورماليزيشن. فإذا أحد عندكم سؤال عن طريقة في طريقة النورماليزيشن. لا، ميد ممكن ما يجي نورماليزيشن، أو هذا في بارت 10 ممكن يجي نورماليزيشن. أنا دائما أشوف نورماليزيشن أما في ميد ترم أو في نهاية. خليني أتأكد من أي واحدة منه. ممكن يجي في الميد ترم، إنه ميد ترم I think up to part 10. أوكي، ممكن يجي في الميد ترم كمان. بس SQL أكيد يجي في الميد ترم. SQL يعني في ميد ترم وفي نهاية كمان. طيب anyone else has any question؟ ما شاء الله. I hope that you are all listening to the lecture. Are you with me? I know you are with me and that about all other students. It is going about. لا 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 very, no, it's very good. It's very good that if you have a discussion, it should be it will clear the topics more. It will be good for you and ينفعك وينفع الجميع الطلاب وينفعني كمان. فهذا شيء جيد كويس ما شاء الله. طيب very good that you understand the concept of normalization, and I hope that once you get anything, I mean in the exams you will do that normalization. The next thing here is representing the relationship between the tables. Whenever we create these tables, okay, for example, here we create 4 tables out of one table. Here also we create 4 tables out of one table. So how do we create a relationship between the tables? So for example, every patient seen by a doctor, okay, so it is one to many relationship. A doctor sees many patient, fine. So how do we create a relationship between these? Every prescription has associated patient, okay, with a drug. So how do we create a relationship between these drug and the patient and the prescription? Okay, so every drug is prescribed. A drug may be prescribed in some prescriptions. So there exists a relationship. That's why it is called as a relational database. Okay, because there exists a relationship between the tables. So how we make the relationship very simple is that we use foreign keys wherever it is necessary. For example, for every patient to be seen by a doctor, we need a doctor ID to know which doctor is seen by which patient. Okay, so what we do, it is a one-to-many relationship. We will take doctor ID, the primary key of doctor table, as a doctor ID into the patient table as a foreign key. We call that as a foreign key. This is a foreign key. Okay, like the primary key. Similarly, a prescription has a date on a patient ID is prescribed on a drug on a particular date. Fact, a patient is prescribed a drug on a particular date. Okay, this is the uniqueness. So patient ID is related. So patient ID is a primary key and at the same time it is a foreign key. Okay, and date and drug code. Drug code is from the drug table. So it is also creating a relation here. Drug code is a foreign key and at the same time it is a primary key of this table. So it creates a relationship between drug uh, and a patient. Sorry, the prescription and a patient and a doctor. So if I say uh, get the name of the drug taken by the patient P001, get the name of the drugs taken by the patient P001. So what you will do, you will go here, patient ID, okay, it's a drug code, and from here you go to see the drug code and the drug name. So you write SQL here. Okay, what you write, select drug name from prescription comma drug, where prescription.drug code is equal to drug.drug code. This is what you write. I'll write it here, select drug name. Okay, so I will say drug name from where, from prescription and drug. I have to take the both. So from prescription comma drug, this is kind of join here. Okay, where prescription dot drug code is equal to drug code. Okay, so I'll get the drug name from here, where this drug code should be equal to this, and then I'll take this name. Okay, if any drug code is not here, this name will not be taken. So it says for patient P001, you can add here and patient ID equals P001. If it will take only for patient P001, their drug codes, it will check their drug codes here and take the drug names. Right? So that's why we need to create a relationship here. So creating a relationship, what we'll use foreign key. So foreign key creates a relationship between a referenced table and a referencing table. In the doctor patient table, doctor column from patient table, that is patient to doctor ID, is a foreign key, matches a primary key of the doctor ID. Okay, this represents a one-to-many relationship between doctor and a patient. That is, one doctor is responsible for many patients. So it is a doctor, okay, and here is a patient. So a doctor is responsible for many patients. So doctor see many patients, and in this case what we do, we take the doctor ID, the primary key here, as a foreign key into the patient table, along with the patient ID and patient name. So this creates this relationship between the patient and the table. So how we represent the relationship? We represent the relationship by using the foreign keys. The example is given here. So this is a referencing table. Patient is a referencing table where we have the foreign key, and doctor is a referenced table, which we have that primary key, which is taken as a foreign key. So referenced table, this is where we reference it. And what is referencing table? This is what the referencing table, which is referencing to doctor. Okay. The referential integrity constraint enforce the integrity of the primary key and foreign keys. So what is that referential integrity? The value of foreign key in referencing table, that is in the patient table. In the patient table, the doctor ID in the patient table either be null, must either be null if there is no patient, no doctor seen by the new patient. So I will add a new patient P009. No doctor see this, so it can be null. So it is either null or one of the value of primary key of the referenced table, or one of the value of primary key of referenced table. So it can be one of these. So what it will be, for example, I have a patient table here, okay, and here patient ID, patient name, and doctor ID. Okay, this is a referencing table, patient, and I have a doctor table here, doctor ID and doctor name. This is a doctor table. This is referenced table. I have doctor D1 whose name is XYZ. I have a patient P1 whose name is ABC. Okay, who's seen by doctor D1. Okay, so what will be the this is a foreign key. So referential integrity is that the value of foreign key, the value here of the foreign key in the referencing table, this is a reference, must be either null. So here null. How null? For example, I add new patient whose name is MNC, not seen by any doctor. So here it can take null. Okay, so either null or one of the value of primary key of the referenced table, or it can be D1, or if I have a D2 who is MOC, for example, either null or it can be any value of this, not other than this. So doctor ID cannot take P01. This is wrong because it is not in the domain of doctor ID. Okay, this is what we call it as a referential integrity. Referential integrity. The value of the foreign key must be null or the value of the primary key of the referenced table. They're enforced by the DBMS whenever we have these referential integrities. When we enforced by the DBMS, when a row containing an invalid foreign key value inserted in a referencing table, this should not be inserted. Okay, when a foreign key referencing table is updated to an invalid value, or when a row of the reference primary key is deleted from the referenced table. From the reference table, if it is deleted, for example, I have here Dr. D1 is seen for the patient 1, but I delete this D1. So then there is no D1. So what this should be done? So DBMS will say to this what to do. Don't allow to do delete this or delete this also. Okay, like this. So we will see that. So what are the restrictions here? We can say restrict. Prevent referenced primary key being deleted. Don't delete the doctor. Don't delete Dr. D1 because it is already seen by some patient. So don't delete it from the table. Or set null. If you are deleting, then set that to the null. So I have a patient here, okay, P1, seen who is ABC, seen by Dr. D1. and I have a doctor table. I have D1 doctor XYZ. So if I delete this, then what will happen? This to this, what should happen? One is restrict. Don't allow to delete this. If you delete, no delete. Don't allow to delete this because already exists as a referencing in a referencing. Second option is null. Delete this and set this to null. Third option is set default. Some default doctor. For example, I have a doctor D0. Okay, he is a general practitioner. So any doctor deleted from here, and if it is in referencing, keep this as default D0. Set default or cascade. Cascade, it means if you're deleting this D1, delete the patient which is also seen by the D1. This is called cascade. So 4 effects or 4 actions can be taken in this referential integrity, which is restrict, set null, set default, or cascade. Okay. Finally, joins. Here, whenever we want to take the data from these relations with these tables, which are joining each other, then we can make which are related to each other, then we can make joins to take the data from these tables. For example, as I gave an example of from here, we have in this table. So I gave an example of selecting the data, right? So let's say, for example, I want to know who are the doctors, names of the doctor who treat the patient P01. Okay, this is another example. Print the name of or display the name of the doctor who treat the patient P01. Very simple. Select doctor name. Okay, from patient, comma doctor. This is join. Where then you write the where condition. Where you write the next line. Where patient dot patient ID. Sorry, patient dot doctor ID is equal to doctor dot doctor ID and patient ID equals P001. So for patient P001, doctor ID and patient whose doctor ID is matching here with this doctor ID with this doctor ID, you select the name. So what it will do, it will print me the name of the doctor who is treating patient P001. So how it is possible? It is possible through joins. Okay, this is called joins. So when we make joins, it is possible that we can take the data from different relations. Okay. So further, you have here normalizations, anomalies, and all. So you can take these, invoices, create the table, and do normalization. Okay, this will be a good practice, and you may get a questions like from here in your exam. Okay, what else we have here is anomalies. We already discussed this. Fine. Device book edition. This is very good. Okay, this is about the join. As you can see here, this query says that it says give a select skill select state that perform join on doctor and patient. So we want to know doctors and the patients, doctor and the patients who are treated by these doctors. So we select a star, okay, from doctor and patient on doctor ID who is in the doctor should be equal to doctor ID who is in the patient. That is, these are all doctors and the patient information and the treated patient information. Okay, this is possible through join. As you can see here, this will be the result for this. Okay. Okay. So what does each row represent here? Each row represents the doctor and its treated patient. Okay, that's what it represents here. and no information is printed for those who does not have a doctors. If there is any patient does not have a doctor, will not come here. Why? Because of this condition that doctor ID in the doctor table should be equal to the doctor ID in the patient table. So it will get only the patient and the doctors who are in relation, the doctors who are treating the patients. And any patient who has no doctor will not be displayed here. Okay. So this is what you have here in normalization. It's an important topic for for designing the databases. Okay, very important topic for designing the databases. You need to practice this. This will come with a practice. Just you need 2-3 examples like patient, doctor, or you can also take the example of student and the teacher, university example. Okay, how you normalize, how you create a tutor separate table, a student separate table, registration separate table, course separate table. For example, a student register in a course taken by the tutor, some tutor, right? So what information you have here in this case, you will have a student information, let's say student ID, student name, his mobile number or email or something like that. You will take other information for course, for example, course code, course name. You will take course name, okay, and the price of the course. You will also take tutor data, tutor ID, tutor name, tutor mobile, for example, like this. So you have all the data in one table. Okay, a student take a particular course given by a particular tutor, fine, or a student takes a particular course. Okay, one student cannot take the same course, so you can take student ID and the course code as a relation, as a primary key. So primary key can be selected as student ID and course code, because one student will take one course at one time. Okay, so in this case, you see uh, how you can normalize this table into first normal form, into second normal form, and into third normal form. Okay, and what you should get, you should get a student table, you should get a tutor table, you should get a course table, and you should get a registration table. Might be you can add a registration date here, course code, course name, student ID. Okay, and here you can add registration date, on which date the student is registering. Okay, so registration table should have a student ID, the course taken, and on which registration. Okay, similarly it can also add the tutor ID if you want to know which tutor is assigned to this, or you can take it here in the course table, course code, course name, and the tutor who is taking the, who will responsible for this course, student ID, student name, and the registration or which course he has taken. Fine. Similarly, tutor ID, tutor name, this you can have. So like this, you need to take the examples and do the normalization. Okay, so with the practice you will get what is normalization. Fine, so this is about the normalization. We'll move to the next topic, which is relational database part 2. So in this we have very simple topic here, which is about SQL set operations, intersection, and difference. Okay, and also we'll talk about SQL subqueries. This will describe how select statement can be embedded within another select statement to enable us to compare data from two or more tables. Okay, so we'll take these two things. Fine, and then there will be another topic called recommender system. Okay, we will take this recommender system in the next class. So we'll just have a break of 5 minutes and then we will take these two things. Okay. Basically, it has been taken from the relational algebra. You have seen set operations in different courses, right? In mathematics, basically it is derived from the mathematics. I think you have seen the set operation even in Python. Okay, in notebook 0.13 in data structures of set data structures. I have, I think, that let me see here. 1.3 derivation anomalies. Yeah, here Python data structures. We have list and tuples and sets. So set operations, we apply different set operations. We have a set operation called intersection, or it is by and, or intersection. Basically, it means what? Intersection, it means tables, the data from which is common in two sets. Okay, that is intersection. And union is, or union, it means data from both the sets. Okay, we also have a difference. For example, set 1 minus set 2, set 1 difference set 2, it means data from set 1 which is not in set 2, or set 2 minus set 1, it means data in set 2 which is not in set 1. That is the difference. The same is applied here. The same is applied for union, intersection, and difference. So you can see that, I think in exercises, yeah, in exercises it is given that these figures we have, this is an intersection, this is union, this is B difference A, the data which is in B not in A, and A difference B. Okay, and this one is either you can combine these two, fine, or you can combine these two to get this. This is called, we have a good name for this. This operation is called symmetric difference. It is A difference B union B difference A, or A union B difference A intersection B. That is there. Fine, you will get that symmetric difference. Fine. Union here, this is intersection. It means that data which is in common in both, and this is union, the data which exist in both. Okay, common and uncommon data. And this is B difference A, data which is in B, not in A, and this is A difference B, data which is in table A, not in B. And this is a symmetric difference. Okay. Now here we can apply this on in SQL by writing with the select, or you can write in intersect. Intersect is nothing but the intersection. Okay, and except is nothing but the difference. Except is nothing but the difference. Okay. Right. So these are the operations we can apply. You can have a union, you can have an intersection, and we have difference. Next topic is subqueries. Subqueries are nothing but query inside another query. Fine. We can write a query inside another query, which is also subquery. There are three types of subqueries. One is called scalar subquery. Scalar, it means this subquery will generate one value, one row, one column. That is called scalar subquery. So in a scalar subquery, the subquery will generate one row, one column, one value. Okay. So a scalar subquery can be used whenever a single value is needed. For example, select clause and in a where clause or in a having condition, you just need only one value. In the where condition, you need one value, and in a having condition, you need one value. So there you can use. Right. Row subquery is nothing but that generates one row of two or more columns. So it generates one row of data for two or more columns, not more than one row. So a row subquery can be used whenever a single row is needed. For example, in the where clause or in the having conditions, if you need only one, or in the from clause, if you need only one row, you use the row. And a table subquery, it is used in the from clause, which returns one row and one or more columns and one or more row. So the data of table subquery is like in a form of table. It can have more than one column and one row. And this can be used in from clause as well as in other having and where clauses. Okay. So example to these subqueries, for example, I want to know who are the patient whose weight is average greater than the average weight. So I can say select star from patient where weight of a patient is greater than AVG, average of weight. This is wrong because you cannot use the aggregate function inside the where clause. So this is totally wrong. So in this case, I can use a subquery here. What I will use, I will say bracket select average of weight from patient. So average of weight is what? It is one value. So here it will return one value. Okay, it is a scalar subquery. It will return one value here. So average weight, for example, it will return average weight is 123.5. So it will be 123.5 here. Okay, and whoever the weight is greater than 123.5, their patient details are displayed. Okay, so like this we use the subqueries. So we can use subqueries here. We can use subquery in different places. Okay, I have seen here solution file on this subqueries. Okay, I'll just show you here. It is there in the notebook. You can check the notebook 11.1 SQL solution set subqueries. Okay. Sorry, this is set operation subqueries. Yeah, here it is 11.2. Okay. So in 11.2 you can see that. So for example, here you see the same select patient ID, patient name from patient where weight is less than the average weight of patient. Similarly, greater than the average you can also check. Okay, so in the where clause we cannot use the aggregate function, so we write this subquery. Okay, and also here display the year where the average weight of patient born in the year is less than the average weight of all patient. Okay, display the years where the average weight of patient born in that year is less than the average weight of all patient. So what do you want here? You want the year of birth and the average weight whose weight, okay, for every group whose weight is less than the average weight of all patients. So you want in a group, okay, years group. So what we'll do, we group by year, okay, having average of weight is less than the average weight of all patients. So here average weight aggregate function you can use in having, but like this you cannot use in where clause. You can use subquery in the where clause like what you have seen here, but you cannot use aggregate function in the where clause. So here you can, in having you can use that. Fine. Similarly, you can also see some example of row subquery here, okay, and table subquery here. Fine. So for example, a select count of star. This is give the number of doctors who are currently treating both male and female patient. So both male and female patient will select doctor ID patient name where gender is F, intersect doctor ID and patient ID where gender as M. Right. So we can select both doctors who are treating male and female patient. Okay, and their count will be displayed. Their count will be displayed. So you can refer to this notebook 11.2 to understand subqueries, 11.1 to understand the relational set operation. So we have used here union operation, except operation. Okay, so you can intersect operation is also used here. So you can do this in SQL from 11.1 and 11.2. Right, that's about the subquery. Then we have a recommender system. So I'll stop here for today. We already taken 2 topics